Hello again. Today we're going to be looking at gravity. What is gravity? But before we get into that, let's remind ourselves what we did last time with this quick quiz on Newton's second law. We went over all of Newton's three laws. First law of inertia, just like Galileo. Second law talked about force and acceleration and mass and how they were all related. So check out this quick quiz. And then the third law says for every action, there was an equal size and opposite reaction. We needed to know Newton's laws so that we can understand orbits and Kepler's laws in a deeper way. Next piece of that puzzle, before we get to orbits, is gravity. Because Newton actually had another law, a fourth law, about gravity. So today we're going to be talking about Newton's universal law of gravity. It builds on his three laws and it gets us one step closer to really understanding orbits. Okay, so here we go. This comes from section change. I don't know why the default is red on this tablet, but anyway, this comes from section 3.3 in your OpenStax textbook. What is gravity? We're going to start by gravity that's more familiar with us, gravity on Earth. And then we'll get into space and orbits. Okay, but let's start with what we know and sort of what makes sense to us. Newton's second law says that if you have an unbalanced force, you are going to get acceleration. So that's all gravity is. Gravity is an unbalanced force that is causing acceleration towards Earth. Toward Earth. Okay? In other words, we have this big mass of the Earth and it's pulling on us, causes us to feel a downward force, an unbalanced force. Now, this acceleration, we're going to spend a little time thinking about what that is. The acceleration that's due to gravity is caused by the mass of Earth. Okay? And since all of us are on Earth, that acceleration due to gravity, whether it's for an apple or for you or for me, is the same. Okay? Be careful here. I'm talking not about the force, I'm talking about the acceleration. Acceleration, again, it's that change in motion. That's that speeding up, that slowing down, that changing direction. In our case, it's the speeding up towards Earth. So the acceleration due to gravity is the same for all objects on Earth. That Earth is an important part here. It's not the same if we go to the moon or to Mars. It's the same for all objects on Earth, no matter how big, small they are, regardless of their mass. Mass is how much matter there is. Okay, the acceleration due to gravity, we give it a special little symbol. It is g. Okay, so we're going to start using this. I'm just going to write it here. I'll use it actually on the next slide. Little g equals the acceleration due to gravity. Okay, sometimes you see that. I want you to know what that means. Okay, so it's hard to think about forces and acceleration, but we know that by Newton's second law that these two things are related, but they're not the same thing. Okay? All right, I'm also, in my playlist today, I'm going to give you a video called What is Gravity? And that's going to go over some things that gravity is not, some misconceptions that we have about gravity. So be sure to watch that video and compare it to what I'm saying in the notes. See how not all of the things that we think about gravity are always correct. Okay, so let's talk about something that is very closely related to gravity, and that is our weight. Okay? So weight is the force. Right, we are talking about the acceleration due to gravity, but weight is a force. It's the force that the object experiences because of the acceleration due to gravity. Okay, the force an object experiences due to the acceleration of gravity. Okay, remember Newton's second law, force is a mass, how much matter is there, times the acceleration. So if our acceleration is due to gravity, little g, then the weight that we feel, W, is just how much of us there is, mass, how much matter there is, times that acceleration due to gravity. This is force times mass times acceleration. This is Newton's second law, right? This is Newton's second. But we are now just writing it in terms of gravity and something that we are all familiar with, weight, right? So weight is a force due to gravity. When we step on the scale, it's our weight. This little acceleration is the same for me or for the apple, but our weight is different because we have different masses. All right, all tracking? Let's take this one step further and say, well, what happens if we're not on Earth and there's a different acceleration? Then we have a different weight. This is why when you go to the moon, if you ever get to go one day, astronauts that go to the moon, they feel a weight that is different. They can bound around because they feel lighter. They haven't lost weight, so to speak. They haven't lost mass. They have the same amount of mass, but their weight is different on the moon or on other planets because there's a different gravity. Okay, because of a different acceleration due to gravity. Okay, a different acceleration due to gravity. So there's a different g. It's not the same g. I'll put that in parentheses. Not the same little g. On Earth, little g is about 10 meters per second squared. But it's different on the moon. Why? Why is gravity different on the moon than on Earth? This is the second really important building block as we're trying to understand where we're going here. Okay, the first building block is this idea of acceleration and what we've been talking about. But why? Why is it different? It's different because the mass of the planet is different. Okay, this is because of the different mass of the planet or the moon. It's not that you have a different mass. You are exactly the same. Look a different size in this little picture, but you're the same. You're not gaining or losing any mass. But the Earth has a lot more mass than the moon does. And it turns out that if the mass is different, gravity is different. Okay, hold that thought. Different mass, different gravity. All right, don't forget that. Okay, now I'm gonna stop this video here in just a second. We have a clicker question for you here. But I also want you to watch a couple of videos, one called What is Gravity and one Misconceptions about Falling Objects. Don't skip those videos. Those are good videos, okay? So answer this clicker question, watch those videos, and then we'll talk about Newton's universal law of gravity.